Now, starting with the periodic properties. So, we have learnt it in the regular classes about the periodic properties. Now, here we are going to study a little bit more about it. So, this earlier attempts was made about the periodic classification first by Daubigny. Then after that we are having Newlands. Then after that we have Lothermeyer's. So Lothermeyer's, we have got a graph or the curve, we can say that, where the physical and chemical properties of the elements are periodic functions of their atomic volume. So one credit we can give to Lothermeyer is that Lothermeyer's graph of course did not say much about it. It said only three particular points, that is the peak of the graph, the ascending portion of the graph and the descending portion of the graph, which I have already discussed with you. But one credit which can be given to Lothermeyer is that he was the person who first found out the periodic function of the atomic volume. That means according to the atomic size of the atomic volume, the periodicity of properties means the periodic properties, we can say it changes. Alright, the periodic properties changes according to the atomic volume, and he was the first person to find out the the atomic density and the atomic volume, or the atomic size today we call it as. Clear? So in this way, that credit we can give to Lothermeyer, even if the Lothermeyer's graph was not fully did not say us anything about the periodic classification. It was not the fully, it told us anything about, just 3 points it told us so it did not tell anything much about it. Next, actually there was Dumas, actually the scientist who formed a homologous series for classification of elements. Actually, you have learned homologous series in nomenclature, in naming of organic compounds, where the compounds are arranged in according to their family, according to their group. Like we have got homologous series for alkanes, we have got homologous series for alkynes, we have got homologous series for aldehydes, ketones, alcohols, in this way. Similarly, Dumas formed a homologous series for the classification of the elements. He tried to form a homologous series for the classification of the elements, so to say. Dumas. Alright, that is for metals, for non-metals, in this way. But he was not successful in his attempt. But at least he tried to form a homologous series for the classification of the elements. Next was Proust. Proust's concept was that every element is made up of hydrogen, and hence the masses of the elements are multiple integral of atomic masses of hydrogen. Now every element is made up of hydrogen means what? It's not that every element contains hydrogen. Means every element combines with hydrogen to form some other compounds. Every element, it combines with hydrogen to form some other compounds. Got it? Because he believed that hydrogen was the most reactive of all the elements. Now this belief was there with Mendeleev also. Alright, Mendeleev also he believed this particular thing. Actually, let me tell you, Mendeleev studied all this periodic table and he made his own periodic table accordingly, and it should be also. Alright, so Proust's concept was that every element, it combines with hydrogen, is made up of hydrogen, means it combines with hydrogen and it forms a compound. And hence the masses of the elements are multiple integral of atomic masses of hydrogen. That means the masses of the elements are in integral ratio with that of the hydrogen, we can say that. Got it? For example, like sodium hydride it forms. So sodium is to hydrogen, the ratio of masses is in integral ratio. Similarly, hydrogen combines with oxygen. So the ratio with hydrogen is to oxygen is a simple integral ratio, we can say that. That was given by Proust, we can say that. So when the elements combines with hydrogen and it forms a compounds, then the masses of the hydrogen to that of that particular element is a simple integral ratio. Integral means what? That is a integers, we can say that. Clear? That is a simple integral ratio, we can say. Clear? Now fine. So this was some of the the periodic classification which was given by especially Dumas and Proust. You did not study, which was given by the earlier chemist about the periodic table, but later on you know that it came your Mendeleev's periodic table, and from Mendeleev's periodic table little bit we came to know for the first time there was a meaningful classification. After that it was Moseley's periodic table, which actually is a long form of periodic table which you are studying it today. And let me tell you, the modern periodic table is mainly contributed by Bohr and Werner, and it is also known as Bohr-Werner's periodic table. WERNER''S. Bohr-Werner's periodic table is also being called as. It was mainly contributed by Bohr and Werner, we can say. So Bohr actually what he did, he did the work upon the atomic numbers, we can say that, clear. And Werner also helped him in what you can say, arranging this particular periodic table, we can say that, arranging according to the atomic numbers, we can say that, in the periodic table. Like Mendeleev, what he did now, he made the cards and he wrote the atomic weight, he wrote whatever the properties he knew on this particular card, and he arranged in the increasing order of atomic weight. Similarly, Werner also helped Bohr in finding out the atomic number, and he also helped it in arranging the elements. Apart from Moseley, we can say that after the work of Moseley, I should say that he did it. Now, so hence this periodic table, for that reason, is also called as Bohr-Werner's periodic table. Remember it. It may come somewhere in your exams, we can say that. Clear? Now, we know that in this particular periodic table, we have got 7 horizontal rows, which is called periods, and 18 vertical columns are groups. And you know the name of the groups also. The first group is alkali metals, then alkaline earth metals. Second group, group 13 is a boron family. Group 14 is a carbon family. Group 15 we call as nitrogen family or nicogens. Group 16 is oxygen family or chalcogens. Group 17 is halogen family. And group 18 is nothing but the noble gases or aerogens or inert gases. Now all these things you know about it. And in terms of block, if you say, then S and P block elements, that is group 1 and 2 and group 13 to 18, are collectively called as normal or representative elements, because their properties was similar to what is there in a particular period, or I should say the filling up of the cells was actually done according to Aufbau's principle. The filling up of the electrons in a given shell was according to Aufbau's principle. Got it? So hence it is called as normal representative elements. Like you remember it, if it is chromium and copper, the filling is not according to the Aufbau's principle. So hence they do not come under the normal or representative elements. But the elements of group 1 and 2 and group 13 to 18, they come under it. Got it? Similarly, D block elements, you know, it is transition elements, and F block is inert transition elements, and lanthanides and actinides collectively are called as inert transition elements or the F block elements, you know that. Got it? Clear? Now coming to one of the properties of the this modern periodic table, that is your effective nuclear charge, we can say that. Now in a multi-electron atom, the valence shell electron experience less force of attraction towards the nucleus due to screening or shielding effect. You know what is screening effect? Like in a multi-electron atom, what you find is that is the innermost shell. It acts like a screen to the electrons which is present in the outermost shell. It does not allow the electrons which is present in the outermost shell to come nearer to the nucleus. Alright, that is called a screening effect or shielding effect. Now the magnitude of the screening effect depends upon the number of electrons in the inner shells. So higher the number of inner shell electrons, greater will be the screening effect. You know that. So the numerical value of the screening effect is determined, listen carefully this sentence, the numerical value of the screening effect is determined in terms of screening constant, which is represented by the symbol rho. You can see I have given it here, rho. See, I have written it also, rho is equal to screening constant, we can say that. Got it? So in case of S and P block elements, the magnitude of screening constant increases from left to right across the period and as well as down the group. Listen carefully. In case of S block and P block elements, the magnitude of the screening constant, got it, the value of the screening constant, it increases from left to right across the period and as well as down the group, because down the group is very simple, you know that is number of shells increases. So hence the screening constant also increases, we can say that. And S block and as S and P block elements, the magnitude of screening constant, why it increases? Because as I said you earlier only, in case of representative elements, electrons are filled in the according to the regular, what you can say, Aufbau's principle, according to the rule of the Aufbau's principle. Alright, so hence what you find is that when you move from left to right across a period, the atomic number increases. Alright, the number of electrons is increasing. So hence I said you just now to you, the screening effect increases and thus the screening constant also increases. Now what you can say is that thus coming to the effective nuclear charge. Now you know that the charge of the nucleus, just now I said you, when you move from left to right across a period, that is the number of electrons increases. Definitely number of protons will also increase. So nuclear charge also increases. So as a result of which there is a decrease in nuclear charge, got it, on the nucleus, as a result of what? As a result of screening effect or the shielding effect. Because in a multi-electron atom, just now I told you, you can see it on the screen also, it is written there. That is, the valence shell electrons experience less force of attraction towards the nucleus. Because I said, the innermost electrons acts like a screen. It does not allow the electrons in the outermost, it does not allow the electrons of the outermost shell to come nearer to the nucleus. So due to which, what I find is that there is a decrease in nuclear charge on the nucleus. This reduced nuclear charge is now termed as effective nuclear charge and is represented by Z star. And Z star is equal to Z minus rho, where Z is atomic number. Alright, so effective nuclear charge increases from left to right. So we can say that left to right across the period, the effective nuclear charge, it increases from left to right across the period. Understood now? So mathematical relation of the effective nuclear charge is Z star, we can say that. Understood what is effective nuclear charge? When you move from left to right across the period, you know that in multi-electron atoms, what you find is that is the nuclear charge due to the screening effect. Due to the screening effect, listen carefully, that effective nuclear charge, what you find is that is now decreasing. Number of shells is increasing, the effective nuclear charge is decreasing. Got it? So it can be across the period also, it can be down the group also, same thing I have already discussed with you. So this effective nuclear charge, how can you calculate mathematically? That the formula I have given you, Z star is equal to Z minus rho, we can say that. Clear? Now remember it, in terms of this atomic size, hydrogen atom is the smallest atom and Fr, francium, is the largest in the size in the periodic table. Hydrogen atom is the smallest atom in the periodic table and francium is the smallest atom in the periodic table according to the atomic size, so to say. Got it? So this is about your, that is nothing but atomic size, and that is about your effective nuclear charge, so to say. Fine. So next we'll come to, that is electronegativity. Now you know that electronegativity, actually the factor is such that it cannot be measured. We do not have any formula to calculate the electronegativity, because electronegativity is what? It is nothing but the tendency of an atom to attract the shared pair of electrons towards itself. Alright, that is electronegativity. But different scientists, they have tried in their own way to calculate the electronegativity. They have given different scale, we can say that. I said you just now to you, electronegativity of an atom is the tendency of an atom to attract the shared pair of electrons. So attract is a tendency. How you will measure the tendency? So it is very difficult. Different scale has been given: Pauling scale, Mulliken scale, then Allred-Rochow scale, we can say that. But the most convincing is the Mulliken scale, we can say that, which is very simple. Is IE plus EA. IE is the ionization energy, EA is the electron affinity. Got it? Whole divided by 2. You will add the value of IE plus IA and you will divide it by 2. That means you will take the average of ionization energy and electron affinity. That will give you the electronegativity, we can say that, which was given by Mulliken, we can say that. Got it? This is the most convincing one, we can say that. Clear? So other I have discussed with you in your regular classes about it. Now if you calculate from this electronegativity, that is, if you calculate the percentage of ionic character, then you know that a particular element has got ionic character as well as covalent character. So together the character is 100%, always remember it, always it's 100%. So how will you calculate the percentage of ionic character from electronegativity? Now what should I do? It will help you to determine the relative bond strength. Got it? Because relative bond strength is directly proportional to the electronegativity difference, mind it. That is the relative bond strength, the strength of the bond, the strength between the two atoms, the bond between the two atoms is determined from the electronegativity difference directly. Got it? So relative bond strength is directly proportional to the electronegativity difference. Okay, fine. And from here only we can calculate the percentage of ionic and covalent character. How? You can see the formula. Percentage of ionic character is equal to 16 chi A minus chi E, that is chi A. Chi A minus chi. Chi E is the unit, is a symbol for electronegativity, chi, plus 3.5 chi A minus chi B whole square. I have written there chi A is electronegativity of the more electronegative atom and chi B is electronegativity of the less negative atom. Got it? So for example, let us say HF is there. So HF will be your, in case of HF, H will be your chi B and F will be your chi A. Remember it. Because fluorine is more electronegative than hydrogen. Got it? Clear? Suppose if you take, that is ammonia. So nitrogen will be your chi A and hydrogen will be your chi B. Over in this way. So this formula was given by A.L. Allred. Got it? This particular formula, 16 chi A minus chi B plus 3.5 chi A minus chi B whole square, to calculate the percentage of ionic character, was given by A.L. Allred. A-L-L-R-A-D. Got it? Now, what we'll do with this? Now, if the difference in electronegativity, that is chi A minus chi B is equal to 0, then the bond is purely covalent. 0. Definitely. Suppose a fluorine molecule, whatever will be chi A, that will be chi B only. Because F and F, one F, let us say chi A, another F will be what? Another element or what? Same thing it is. For oxygen, O2, 2 oxygen is there. So chi A and chi B is same. The difference in electronegativity will be same. For example, hydrogen, chi A and chi B will be same. Isn't it? Chi A means what? That is electronegativity of the atom A. Here both are same. When I say O2, when I say H2, when I say F2, when I say Cl2, what does it mean? It means Cl, single bond Cl. So chi A is Cl, chi B is also Cl. So difference in electronegativity will be 0 definitely. So hence you know Cl2, O2, H2, F2, N2, they are all covalent compound, purely covalent compound. They are non-polar in nature. We can say that. So if the difference is less than 1.9, then the bond is said to be polar covalent. We can say that it is covalent if the difference is less than 1.9. In certain book you will find 1.7 also it is there. Now if the difference is equal to 1.9, then it is 50% ionic and 50% covalent. Now if the difference between chi A and chi B is greater than 1.9, then the bond is ionic. That means if the difference between a chi A and chi B, that means if the electronegativity difference increases more than 1.9, then the ionic character increases. And if it is decreases less than 1.9, then the ionic character decreases and covalent character increases. That's it, I can say in short. So in this way, percentage of ionic and covalent character you came to know. Now next is we'll come to from this difference only we'll come some other facts we will see. That is acidic and basic strength. So difference of electronegativity, that is chi O minus chi A. O means here oxygen. Oxygen atom. O stands for here oxygen. For a bond OA, suppose O is an oxygen, A is another atom. Got it? Like suppose we are having what is that? We can have sulfur dioxide. So O is sulfur oxygen and A is your sulfur. Got it? In this way. Or metallic oxide can be your sodium oxide, potassium oxide, in this way. So now listen carefully here. That is OA, the bond that is between O and O single bond A, decides the nature of the oxide found by the element. Got it? The difference of electronegativity chi O minus chi A for bond OA, A can be any particular element which is metal, non-metal, anything, decides the nature of the oxides found by the element. This the difference of electronegativity. What is that? When chi O minus chi A means difference between oxygen and any other element is large. Got it? The oxide will be basic in nature. Got it? When the difference in electronegativity between oxygen and any other atom, if you find the difference in electronegativity, then the oxide will be basic, like potassium oxide, sodium oxide, calcium oxide, in this way, rubidium oxide. So many. Now if the difference is small, this difference, the oxide will be acidic in nature. For example, carbon dioxide, sulfur dioxide, in this way. It will be acidic in nature. Got it? So the ionic compounds which have ionic character less than 20% are found to be colored. There's another fact is there, another compact fact is there. If it is less than 20%, if you find the difference between chi O and chi A, and you get the difference is less than 20%, the compounds is found to be colored, like AgBr. All right. I know the value, and I am saying you do not have to remember. That is 18% it is, and it is light yellow in color. AgI, which is less than 18%, which is light dark in color, we can say that in this way. So that also we can say the color, we can predict the color. If the difference in electronegativity is less than 20%, then the compounds are said to be color in nature. We can say that the ionic compounds are said to be colored in nature. Alright, so this is about the electronegativity. We can say a little bit about it. Clear? Now, next is some important points which you have to remember, which you may come in your exams. Got it? In somewhere, like in assertion reasoning question, or in fill in the blanks, or in match the column, or in matrix type. Any type of questions it may come, or what you can say, the multiple choice also. Like cesium has the minimum ionization energy among all the known stable elements. Cesium. That is why cesium is found to be the best photoconducting material. It has a minimum work function. Photoconducting means it is used in photoelectric effect, because as it has minimum ionization energy, electrons can be easily released from it, and hence it is the best photoconducting material. We can say that. The first ionization energy of nitrogen is 14.6 electron volt per atom, and that of oxygen is 13.6 electron volt per atom. That you need to remember it. Now, in a period, inert gases have the least electron affinity. You know that. They do not have a tendency to lose or gain electrons because the outermost shell is fully filled. So cesium has, coming to again cesium, has minimum electron affinity except inert gases, and chlorine has maximum electron affinity. You know that. In a particular group, chlorine has a maximum electron affinity. It should be fluorine, but chlorine. You know the reason. Because fluorine is compact in size, and chlorine is, compared to fluorine is bigger in size. Got it? So chlorine can readily accept an electron compared to fluorine. So hence, if you compare the electron affinity of chlorine and fluorine, I have already discussed with you. So chlorine has got more electronegativity, more electron affinity than fluorine. So first is chlorine, then fluorine, then bromine, then iodine. We can say that. Now that is beryllium and magnesium and zero electron affinity, which has NS2 configuration. NS2 means what? N means any principal quantum number. That is, for example, use beryllium atomic number is how much? 4. 1s2, 2s2, 2s2, ns2. The outermost shell is fully filled. Got it? Clear? So magnesium, it is 12. 1s2, 2s2, 2p6, 3s2. Again it is 3s2. Outermost shell is fully filled. For that purpose, it has got zero electron affinity. We can say that. Clear? Just like it behaves as inert gases. Okay? Fine. So now, what you find is that another some important points is there. The polarizing power of the cation is determined with the help of charge to size ratio. The polarizing power of the cation is determined by the charge to size ratio. The polarizing power is determined. You need to remember that. Charge to size ratio, which I have already said, it is nothing but known as your ionic potential. We can say that. Clear? So metals, that is francium, then cesium, then gallium and mercury are known in liquid state at 0 centigrade. This is very important. Now, order of relative stability of the half-filled and fully filled orbitals, you need to remember D5, then P3, then D10, then P6. It is in this order. Here, this is the order of relative stability. First is D5, then P3, then D10, then P6. Got it? The sulfur forms the maximum number of oxy acids, and all oxy acids are dibasic. You will be reading it in class 12. That sulfur forms H2SO5, peroxomonosulfuric acid. It forms, which is also known as Carrow's acid. Yeah, remember it, Carrow's acid. Of course, you'll read it later on. H2S2O8, peroxodisulfuric acid, which is called as Marshall's acid. Marshall's. Got it? Acid. In this way, many more compound sulfur forms, many oxyacid sulfur forms. So this is it. Apart from sulfurous acid, sulfuric acid. Then what you can say, we have read it also, H2S2O7, which is oleum. Got it? You have read it. So many more are there. The third oxides of carbon, that is C3O2, carbon suboxide, which has a linear structure. You draw the structure and see it is linear. Got it? It is 180-degree bond angle. F2O is fluoride instead of an oxide. Remember it, very important, because fluorine is more electronegative than oxygen. So it is fluoride. Oxygen is not electronegative here. Fluorine is more electronegative. You know that in case of electronegativity, fluorine has got the highest electronegativity. Highest. So any compound containing fluorine is known as fluoride. Got it? It is fluoride. So here F2O is not an oxide, it is fluoride. Got it? Clear? You can also write OF2, no problem. There's no problem in it. Compound in lower oxidation state are ionic, whereas covalent in higher oxidation state. Now, where it is, for example, lower oxidation state like ferrous oxide and higher oxidation state like ferric oxide. So ferrous oxide, you can say that it is more of ionic in nature, and ferric oxide is more of covalent in nature. Alright, so that's it. Any particular compound in lower oxidation state will be ionic, and higher oxidation state will be covalent, like stannous oxide, stannic oxide, cuprous oxide, cupric oxide. Alright, in this way we can say that. Clear? So that is some important points we came to know. The neutral oxides of nitrogen are nitrous oxide and nitric oxide. You must remember it, neutral oxide of nitrogen. Chlorine atom is the most affinity, I told you already, and Cl minus ion is the most stable anion. Remember it. Chlorine atom has got the highest electron affinity, hence Cl minus ion is the most stable anion. Remember it, Cl minus ion. Got it? And nitric oxide is being formed by the reaction of nitrogen and oxygen during thunder and lightning. It is being formed. Okay, fine. Now in this way. Next is we will come to the end of this slide, so we can say that, and we will see it later on some more about it. Thank you.